Ray optics, 4 marks important question, intermediate second year physics. So question is, define focal length of a concave mirror, prove that radius of curvature of concave mirror is double its focal length. First we see focal length of concave mirror. Distance between focus capital F and the pole of a concave mirror is called focal length, is called focal length of concave mirror. So distance between capital F and P is called focal length of concave mirror. Now the derivation of radius of concave mirror is equal to 2 times the focal length. That is question. Prove that the radius of curvature of concave mirror is double its focal length. So now derivation, it is a symbol for concave mirror. So this is a painted part and this is a inner part is a reflecting surface, and here midpoint is there. This is called pole. This is called pole denoted by P, and this is it is a symbol for a concave mirror, and this is a midpoint of the mirror which is called pole denoted by P, and this is principal axis. Now let AM is a incident ray which is hitting or striking the concave mirror at the point M. So AM is the incident ray. So you can see it is a parallel to principal axis. But after the reflection, so this passes through the focus capital F. So it is a incident ray which is parallel to principal axis and strikes the mirror at the point M. So AM is incident ray and this is reflected ray. Now and this is normal which is meeting a point on the principal axis called center of curvature. It is a normal. Now from the point M to principal axis, very close to pole, a line is drawn. This is called perpendicular line. It is perpendicular to principal axis. MD is perpendicular to principal axis. So now this is a normal. Then this is called angle of incidence. This is called angle of reflection. If you take this is a 2 theta, then this will be theta, because so here you can see P angle. So first this is AM is incident ray, MC is normal, MD is also perpendicular to principal axis. Now from this DFM is 2 theta. This is so in this here in this triangle it is exterior angle, and these two are opposite interior angle. So from the 2 theta is taken from the in a triangle, exterior angle equal to sum of two opposite interior angles. From this 2 theta is taken. ఇది 2 theta అని ఎందుకు తీసుకున్నామంటే, సో ఇది ఎక్స్టీరియర్ యాంగిల్, ఈ ట్రయాంగిల్లో ఇవి రెండు ఏమవుతాయంటే దీనికి ఆపోజిట్లో ఉన్నటువంటి, సో ఆపోజిట్లో ఉన్నటువంటి రెండు, సో 2 ఆపోజిట్ ఇంటీరియర్ యాంగిల్, దీనికి లోపల ఉన్నటువంటి రెండు యాంగిల్స్ ఆపోజిట్, ఈ రెండు కలిస్తే 2 theta, that is theta plus theta is 2 theta. So now we want to derive radius of curvature. Radius of curvature is equals to 2 times the focal length. So now from pole to center of curvature, PC equal to radius. From pole to focus is focal length denoted by small f. Now we are taking the triangle, that is MCD or DCM. From the triangle MCD, tan theta is equals to, this is tan theta is equals to, we have a formula, opposite side to theta by adjacent side to theta. So MCD, this is a triangle, theta opposite to this theta, MD, and this will be adjacent side DC. So this implies tan theta is equals to MD by DC, equation 1. Now again we are taking triangle MFD. Triangle MFD. From triangle MFD, but in this case angle is 2 theta. So tan 2 theta is equals to, again formula for tan 2 theta or theta opposite side to 2 theta by adjacent side to 2 theta. So now opposite to 2 theta, 2 theta కి ఎదురుగా ఉన్నటువంటిది MD and DF. MD, so this implies tan 2 theta equal to, opposite to 2 theta means MD, and this is DF, equation number 2. Now when theta is very small, when theta is very small, we can take tan theta is equals to theta, and tan 2 theta is taken as 2 theta, and we are leaving tan because theta is very small, and point D coincides with P. So this implies D is equals to P. D is equals to P. So this means DC equal to PC and DF is equals to PF, because as theta is a very small, D is a touching P. So D equal to P. Then DF equal to PF, DC equal to PF. So now, and also tan theta is taken as theta, tan 2 theta is taken as theta. So from equation 1, this is tan theta is MD by DC. DC means PC we can write. But tan theta, instead of tan theta, we can take theta. That is why theta equal to MD by DC. From equation, consider it is equation number 3. From equation number 2, so tan 2 theta is equals to MD by DF. But tan 2 theta is taken as 2 theta. So this implies 2 theta is equals to MD by DC. So from equation number 3, this implies, from equation number 3, theta means this is, instead of here theta we can write 2 of MD by DC equal to, it is a DF students, it is DF. So 2 into theta. Theta means MD by DC equal to MD by DF. MD cancel. This implies 2 by DC equal to 1 by DF. But here, when theta is very small, tan theta is taken as theta, tan 2 theta is taken as 2 theta. So when theta is a very small, the point D coincides with P, then this implies DC is written as PC and DF is written as PF. So here 2 by DC means PC we can write because it is, and 1 by DF means PF. This implies 2 by PC means, here you can see distance from pole to center of curvature, which is called radius capital R. Distance from pole to focus is called focal length, denoted by F. So 2 by PC means radius R, 1 by PF means focal length. So by the cross multiplication, 1 into R is equals to 2F. So radius of curvature of concave mirror is 2 times the focal length. Then focal length is equals to half of radius of curvature of concave mirror. Most important for 4 marks.